Hi guys, my name is Jay Ganesh. I'm currently pursuing my studies at University Telangan National in Bachelor of Mechanical Engineering. So, I have an individual task given by Mr. Azmi to give a short briefing about something I learned. So, today I'm here to talk about thermodynamics. There are four laws which are zeroth, first, second, third. So, I know most of you all would have heard about thermodynamics but wouldn't know what it is. Let me explain to you all. What okay, let's talk about system. What kind of system are you? Open or closed? As it turns out, this is a physics question, not a philosophical one. You like all living things are an open system, meaning that you exchange both matters and energy with your environment. For instance, you take in chemical energy in the form of food and do work on your surrounding in form of moving, talking, walking and breathing. All of you I mean, all of the exchange of energy that take place inside of you, such as your many metabolic reaction and between you and your surrounding, can be described by the same law of physics as energy exchanges between hot and cold objects, or gas molecules, or anything else you might find in a physics textbook. Here, we'll look at two physical laws, the first and second law of thermodynamics. We mainly focus on first law and see how they apply to biological systems like you. Thermodynamics in biology refers to the study of energy transfer that occurs in molecules and collection of molecules. When we are discussing thermodynamics, the particular item or collection of items that we're interested in, which could be something as small as cell or as large as an ecosystem, is called as system. While everything that's not included in system we have defined is called the surrounding. For instance, if you were heating a pot of water on stove, the system might include the stove, pot and water, while the surrounding will be everything else, the rest of the kitchen, house, neighborhood and everything else. The decision of what to define as the system is arbitrary, up to the observer, and depending on what you wanted to study, you could equally well make just the water or entire house part of the system. The system and surrounding together make up the universe. There are three types of systems in thermodynamics: open, closed, and isolated. Okay, let us talk about open system. Open system can exchange both energy matters with its surrounding. The stovetop example would be an open system because heat and water vapor can be lost to the air. A closed system, on the other hand, can exchange energy with its surroundings, not matter. If we put a very tightly fitting lid on top of the previous example, it will approximate a closed system. An isolated system is one that cannot exchange either matter or energy with its surroundings. Perfect isolated system is hard to come by, but an isolated drink cooler with a lid is conceptually similar to a true isolated system. The items inside can exchange energy with each other, which is why the drinks get cold and the ice melt as little, but they exchange very little energy with the outside environment. So we are like other organisms, an open system, whether you like think about it or not. You are constantly exchanging energy and matter with your surroundings. For instance, suppose that you eat a carrot or lift a bag of laundry onto a table or simply breathe out or release carbon dioxide into atmosphere. In each case, you are exchanging energy and matter with your environment. Exchanges of energy that take place in living creatures must follow the law of physics. In this regard, there are no different from energy transfer in, say, an electrical circuit. Let's take a closer look at how the law of thermodynamics works. Let us talk about the first law of thermodynamics. The first law of thermodynamics thinks big. It deals with total amount of energy in the universe, and in particular, it states that total amount does not change. Put another way around, the first law of thermodynamics stated that energy cannot be created or destroyed. It can only change form or transfer from an object to another. The first law stated that amount of heat given to system is equal to sum of internal energy of the system and the external work done. This law may seem kind of abstract, but if you start to look at examples, you'll find the transfers and transformations of energy take place around us all the time. For example, light bulbs transfer electrical energy into light energy. One pool balls hit another, transferring kinetic energy and making the second ball move. Plant converts the energy of sunlight into chemical energy stored in organic molecules. You are transforming chemical for energy from your last snack into kinetic energy as you walk, breathe, and move your finger to scroll up and down. Your phones. Importantly, none of these transfer is completely efficient. Instead, in each scenario, some of the starting energy is released as thermal energy. When it's moving from one object to another, thermal energy is called by a more familiar name of heat. It is obvious that glowing light bulbs generate heat in addition to light, but moving pool balls do too, as do the inefficient chemical energy transfer of plant and animal metabolism. Let's talk about first law of thermodynamics. First law of thermodynamics is essentially the conservation of energy principle. The first law stated that energy cannot be created or destroyed during any processes. Energy only can change its form from during any process occur. For example, heating, freezing, melting, boiling, and many more. There are significance in first law of thermodynamics. For example, total amount of energy in this world is constant. It is impossible to get extra energy out of a system. You cannot create energy from nothing. Yeah. Jump to conclusion. The first law stated that energy will remain constant in closed system, regardless how it changes or moves around. To add energy into a system, it could come from somewhere else. So guys, thank you so much. Please like this video. Yeah, I need a 50 likes. Please do like. Thank you.